Unit 6, Video 3, Writing Equations of Quadratic Functions, from tables and from graphs. Thinking of from graphs, just work backwards. You're going to identify the vertex and then identify the zeros, which is also known as the x-intercepts. So here's an example. The graph has zeros of -5 and -2. So that means we know x equals -5 and x equals -2. Knowing that we've gone the other way, we factored these, so we're going to put them in factored form. So that means this looks like x plus 5 and x plus 2 is equal to 0 when I'm writing it out in an equation. And then I'm simply going to just go ahead and multiply through. And when I do that, I get x squared plus 2x plus 5x plus 10 is equal to that 0, which simplifies to x squared plus 7x plus 10 is equal to 0. And that would be the equation that goes with this. Next example, we know that the vertex is 2, -3, and another point on the graph is 5, 6. So this, we're going to use that equation, our vertex form of the equation. Okay, there's a nice little rememory of y equals a, parentheses, x minus h, parentheses squared, plus k. So we're going to start plugging in what we know. Well, we have a point, so we have our x and our y. We have the vertex, so we have our h and our k, but we don't know what this a is. And we need the a so that we can do this entire equation. So I'm going to plug in everything I know and then solve for a. Now notice, this point is my x and my y. So my y is 6 and my x is 5. So I'm just substituting that in. This is my vertex, which is my h and my k. So my h goes right here and my k goes right there. So now I'm just going to keep doing the math, simplifying as I go and solving for a. So as you see there, I just did inside the parentheses, 5 minus 2 is 3, and I'm going to keep going. Order of operation is very important. I needed to square the 3 before I multiply it by the a. Now I'm going to move it to the other side. I'm going to add 3 to both sides. When I do that, when I'm adding 3 to both sides, I get a 9 on the left side equals 9a. So divide both sides by 9, and I'm left with a equals 1. So now we're going to plug it back into the formula at the top using my h and my k because I know that's the vertex. And by the way, a does not always equal 1. It just happens to equal 1 in this problem. Sometimes, though, you're going to have a different value for a. So then this is the equation, y equals 1, parentheses, x minus 2, parentheses squared, plus -3. And you can totally leave it in this form because this is the vertex form that we have been working with. All right, next example, we know the vertex is -1, -3, and one of the zeros is -5. So we are going to use the same concept we did in the last problem because we have a point and we have the vertex, but we need to define what that point is. So we know the vertex, but remember, if one of the zeros is -5, the point that goes with that is -5, 0, because that is the x-intercept, and that's how I write it in an ordered pair form. So we're going to use the vertex form. And again, we're going to replace the x and the y with the point that I've established there, that -5, 0, and the h and the k with that -1, -3. So as you can see, my y is a 0, that's coming from here. My x is a -5, that's coming from here. My h is a -1, so I even left the -1 in there just for the time, and my k is a -3. So now I'm going to go ahead and simplify in that equation. Following suit with order of operations, I had to do inside the parentheses first. Now I can actually do the squaring part. So now I'm going to go ahead and add 3 to both sides and then divide by 16. So a equals 3 over 16. So now I'm going to plug it back in for my a into my vertex form for quadratics. And as you can see here, y equals 3 over 16, parentheses, x plus 1 squared, plus a -3, or -3. So that is the official equation for the situation. I don't need to do any farther. I don't need to go any place with this because that is the equation for this situation. All right, now what about when you're given a table to work from? So we need to look to see if there's a pattern. The x column should be going up or down by the same amounts, And the y column will have the same values when you're looking at that, so you should be able to see a clear middle, which is the vertex. Once you have your vertex identified, choose it and another point to write out the equation like we did in the last couple examples. Okay, so here's the table. So looking for a pattern, I can see the pattern here, especially looking at my y's, -12 and -12, -4 and -4, 0 and 0, 2. So to me, I can do a nice, easy deal that, hey, that's my vertex. 6, 2 is my vertex. So then now I can choose any of the points on this table to use for my other point. I went ahead and you could work with me, and I went through every example possible. But I'm going to choose the 5, 0 because I love it when there's a 0. So again, I don't know what my A is, but I'm going to start plugging in I've got my vertex, which is my H and K, and I have a point for my X and my Y. So I'm going to start plugging it in. So as you can see, I have a 0 for my Y because that's coming from here. That's what my Y is. A, again, I'm solving for. I have an X, which is 5. I have a 6 for my H, and I have a 2 for my K. So now I'm going to go ahead and simplify. Now that I've simplified, I'm going to go ahead and solve for A. So A equals -2. So now I have my A value and I have my vertex, so I'm going to write it in the equation using that vertex form, which is in that yellow there at the top. So my equation then is y equals -2, parentheses x minus 6, parentheses squared, plus 2. All right, next example is shown on this table. So again, I'm looking for the pattern. Looking at this, I see a 22 here and a 22 there, a 13 here, a 13 here, and a 10 here, right in the nice middle, okay? And a lot of times in the problems that we're going to do here, that's where you see it. So here's what I see. That's my vertex. So I'm going to choose that, and I'm going to choose another point, and then I'm going to do exactly what I did. So again, we're going to use our vertex form, and we are going to plug in. This is my H and my K. That goes right here and right here. This is my X and my Y. That goes right there and there. So I'm going to start plugging in things to solve for A. Now that I have everything plugged in the correct place, I'm going to go ahead and simplify. And now I'll subtract 10 from both sides, and I'll end up with A equals 3. Now that I have A equals 3, I'm going to plug in that and my vertex into the vertex form and be done. So as you see, the formula, the equation for this is y equals 3, parentheses x minus 5, parentheses squared, plus 10. Okay, so just in case you're wondering, what if I chose a different point? Yes, you have to have the vertex correct, but as you see here, it doesn't matter what point I chose. I could have chosen any of them, and I still would get the same A value, thus getting the same final equation.